Today we're going to talk about tree diagrams. Before we can get into our examples actually using and drawing out our tree diagrams, we need to talk a little bit about something called the counting principle. The counting principle states, if a first experiment can be performed in m distinct ways, and a second experiment can be performed in n distinct ways, then the two experiments in that specific order can be performed in m times n distinct ways. So what we're looking at here and thinking about our counting principle is we're trying to figure out the total number of different possibilities we have for outcomes. Right? This list of all of our possible outcomes is going to be called a sample space. So we're going to use our counting principle in most of these examples to first find the size of our sample space. Each individual outcome of our sample space is called a sample point. So we're going to talk about these different points and how we can use those to find probabilities. Right? In order to do that, again, we're going to use something called tree diagrams, right? Which is going to give us a way to visualize our sample space. Right? So example one, we're going to start by selecting marbles. Right? So as we're going through and doing these, two marbles are to be selected, right, without replacement from a bag that contains one red, one blue, one green, and one orange marble. So first we want to find our sample space. Right? So looking at our marbles, right, we have red, blue, green, and orange. So for our first marble, we have a total of 4 different possibilities. Right? Without replacement means once we take that marble out of the bag, we're not going to put it back in there. So let's say, for instance, we take the red one out to begin with. Well, then we only have the 3 other different colors left over. Right? So we have a blue, a green, or an orange. Right? And same thing would be true if we took out a blue, a green, or an orange marble. Right? So our second marble, we have exactly 3 different colors as options. Right? So to find our sample space, we're going to use our counting principle to multiply these two numbers together. Right? So we're going to have 12 sample points in our sample space. Right? Now we're going to draw ourselves a diagram of our different possibilities. Right? So looking at this, our first possibility, right, is we're going to take a marble out and we have 4 different possible colors that could be options. Right, so we could draw out a red one, we could draw out a blue one, we could draw out a green one, or we could draw out an orange one. Right, now going back to our red one, if we took that one out, we said we had 3 different possibilities that were left. Right, then we can select a blue one, a green one, or an orange one for our next marble. If we draw a blue marble out, well, then we could select one of the other 3 colors. So we can select red, green, or orange. If we draw a green one out at first, well, then we have a red, a blue, or an orange. And if we draw an orange one out first, then we have a red, a blue, or a green. And if we look at this diagram, it's called a tree diagram because it kind of looks like a tree. My one on the notes that are printed online are a lot nicer looking. But this tree diagram then gives us our 12 different sample points in our sample space. Okay, so over here I'm just going to come to the side and I'm going to list out our sample space. Okay, so our first possibility is red-blue. Okay, then we had red-green and red-orange. We had blue-red, blue-green, and blue-orange. We had green-red, green-blue, and green orange, and we had orange red, orange blue, and orange green. Now that we have our tree diagram made and our sample space listed, we're going to use this to answer our last 2 questions. So in example C, we're asked to determine the probability that an orange marble is selected. So if we look at this, we have 1, 2, 3, 4, 5, 6 different cases, 6 different sample points where we could draw out an orange marble. So our probability of selecting an orange marble Right? We have 6 different sample points out of 12 different sample points in our entire sample space, which then if we reduce our fraction gives us a reduced fraction of 1/2. The other thing we're also asked, right, is what is our probability of selecting a green then a red? So if we look at our sample space, well, we only have one case of selecting a green marble and then a red. So our probability of selecting a green first, then a red second, is simply 1 out of 12. Right? Only one of our sample points out of the 12 in our sample space. Right, we're going to use similar ideas as we go through the next couple of examples. We're going to start by figuring out how many different things we have in our sample space, right, how many sample points we have. Once we do that, we're going to draw out a tree diagram, and once we have our tree diagram, we're going to use that to find a couple of different probabilities. So at Teresa's restaurant, each lunch special consists of a sandwich, a salad, and a beverage. The sandwich choices are roast beef, ham, or turkey. The salad choices are macaroni or potato, and the beverage choices are coffee or soda. Use our counting principle to determine the number of different lunch specials offered by the restaurant. So we have 3 choices for our sandwich, 2 different types of salad to choose from, and 2 different beverage choices. So we're going to multiply all 3 of these items together this time. 3 times 2 gives us 6, times 2 again gives us 12. So we also end up with a sample space in this example of 12 sample points. Right. Now our tree diagram is going to look a little different because we have 3 different events that we're working with instead of just 2. Right, so we'll start with our sandwich. Right, so thinking about our sandwiches, we have either a roast beef, ham, or turkey to choose from for our sandwiches. Right. After we choose the type of sandwich, well, then we have 2 types of salad to choose from. Right? So for each of these, we either have the macaroni or potato salad. Okay. So far we're up to 6 options, because 3 times 2 gives us 6. And now we want to think about our beverage choices. So each of these is going to have 2 choices for beverage. So either coffee or soda. So again, we're going to list out our sample space. And we're going to have 12 different things total. Right? So our first option, roast beef sandwich, macaroni salad, and coffee. Then we have roast beef sandwich, macaroni salad, and soda. Right? Then we have roast beef sandwich, potato salad, and coffee. Roast beef sandwich, potato salad, and soda. Ham sandwich, macaroni salad, and coffee. Right? Ham, macaroni, and soda. Ham, potato, and coffee. Ham, potato, and soda. Turkey, macaroni salad, and coffee. Turkey, macaroni salad, and soda. Turkey, potato salad, and coffee. Turkey, potato salad, and soda. Right, now that we have our sample space drawn out, again, we're going to use this to answer a couple of different questions. Right, so C says, if a customer randomly selects one of the lunch specials, determine the probability that both a roast beef sandwich and a soda are selected. So if we look at our sample space, right, we have a roast beef sandwich and a soda in this case. We have a roast beef sandwich and soda in this one. So our probability of roast beef and soda is going to be 2 out of 12, which then reduces to 1 out of 6. Next, we're asked if a customer randomly selects one of the lunch specials, determine the probability that neither macaroni salad nor coffee is selected. Right? So if we look at our different ones here, right, we can eliminate the top 6 because they all have macaroni salad. If we could look at kind of the next line that I have drawn here for my sample space, all of those include coffee. Right? So it's only going to be these bottom 3 in the way that we have our list drawn out, right, that have neither macaroni salad nor coffee. So our probability of neither macaroni salad nor coffee is going to be 3 out of 12, which then reduces to 1 out of 4 as a simplified fraction. Okay. So our sample space looked a little bit different than our one from our first example. We still had 12 different sample points in our sample space. Again, once we had our tree diagram drawn out, then we could use it to generate a list of all of our events in our sample space, and then we could go from there. All right, one last one that we're going to work through. So in this case, we're going back to our marbles from our first example, but this time we are going to be replacing them. So we have 4 choices for our first marble and 4 choices again for our second marble. Right? It is possible to repeat the colors in this case. Right? So the 4 times 4 is going to give us 16 sample points for our sample space. All right. Our tree diagram. Red, blue, green, or orange. Right, and each of these we're going to have 4 different options. Right, red, blue, green, or orange again. Red, blue, green, or orange. Right, so if we look at our tree diagram, we have all 16 of our different possibilities. Right. So our sample space, we're going to list these out. So we have red, 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 blue, red, green, red, orange, blue, red, blue, 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 green, blue, orange, green, red, green, blue, green, 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 orange, orange, red, orange, blue, orange, green, orange, orange. Right now, looking at this again, we're asked a few different questions down below. Determine the probability that a red marble is selected twice. Well, if we look at our different possibilities here, that happens exactly once, right, in that first sample space. So our probability of red followed by red is exactly 1 out of 16. Our probability that neither is orange. So looking at our list, we can eliminate this bottom row, and we can also eliminate this right column because those are orange. So if we look at the ones that are left in our sample space, we have a total of 9 out of 16. Right, then last but not least for E, determine the probability that the orange marble is selected at least once. Right. So our probability that we have at least 1 orange. Right. Well, that's going to be all of these guys, right, that we just eliminated, right, for example D. Right. So all of the ones in the sample space that I just put a little dot next to, right, those are ones that have at least 1 orange. Right. If we count those, that gives us a total of 7 out of 16. Relating this back to some different things that we've talked about, right? Example D and E are complements of one another. Right? Neither orange and at least 1 orange are complements. Right? Either there's no orange at all or we do have an orange one. So if we look at these two different probabilities, our probability of an event happening at least once, so our probability of at least one orange is the same as our probability of 1 minus, right, neither orange. So in that case, 1 minus 9 out of 16, which gives us 7 out of 16, which exactly matches our answer to E. So again, as we're going through, as you're thinking about these problems, right, we're using our counting principle to determine the size of our sample space. Then we're going to use a tree diagram to actually find and list our sample space. And once we have that sample space listed, we can then use that to determine some different probabilities as well.